To start us off with a couple of examples, all of the client-related stuff I'm going to put on the left. And so up at the top here, I have my client code with my if statement to check whether or not we're on the client. And then down below, the browser, in case we want to play around with client-side debugging. And then on the right at the top, I have my server code with my if statement to check whether we're on the server. And down below, the actual server, which is running our Meteor application. Let's start off by creating a method on the server. To define a method, I can call the Meteor methods function and pass it an object of method names to functions. Let's create one called sayHello. Sometimes you'll see these methods defined in a style that looks sort of like a URL, and that's just an idiom or a common practice. The value will be a function that can take any number of parameters. In this case, we'll say that it takes a name. And then a method, just like a regular function, can return a result. In this case, our result will be a string, and the value will be hello plus whatever the name is that was sent up. Let's call this function from the server. To call a Meteor method, we can use meteor.call. We can also use meteor.apply, and the difference between call and apply is the same difference as with call and apply in regular JavaScript. With call, we pass the name of the function that we want to call, in this case, sayHello. And then any number of parameters that we want to pass to the function. Let's pass my name as the only parameter. And just like in JavaScript, the difference between call and apply is instead of passing the parameters this way, we can pass an array of parameters if we use apply. So it's useful depending upon how you're calling the methods. In this case, we'll just use call. And as a final parameter, we can pass a callback. We'll look at that more when we call this function from the client. Now, when we're on the server, we can get the result synchronously. In other words, the return value of calling meteor.call will be whatever gets returned from the Meteor method. And we can store that result in a variable, just like we have here. So what I'll do is I'll print out the result from the server. And if you keep your eyes trained on the console below, you should see that the result from the server is hello, Chris. Next, let's jump over to our client JavaScript file and call this Meteor method using client JavaScript. I can call the function the same way on the client. So I'm going to say Meteor call, and we'll pass the name of the function, or the Meteor method, and then any parameters. Now in this case, we can't get a result synchronously. Because we're calling this function from the client, it has to make a network call up to the server, and that's going to happen asynchronously. And so we may not get a result right away. So instead of storing the result like this, we can pass a callback function as the last parameter to this function. And the callback function in typical Node style will take an error as a first parameter and the result as a second. That way, when the server responds with a result, this function will get called at some later time. And what I'll do is say from the client, or result from the server, and I'll just print out the result. And we should see that result printed in the console of the browser once we get a result from the server. And here it is down here. Since we made this Meteor call from the client, it had to make a network call up to the server to call the function, and then the server returns the result, which ends up calling our function, our callback function, and printing the result to the browser. When we make a remote call like this from the client to the server, there can be some latency or delay from the time that we make the call to the time that we get a result. So Meteor Methods gives us a way to deal with this by allowing us to run some code on the client even before we get a result. It's called latency compensation, and to do it, we can create something called a Meteor stub. To accomplish that, we'll create a method on the client with the same name as the one on the server. Inside this function, just to demonstrate the concept, I'll say that we're running the Meteor method stub on the client. Now what happens when we use Meteor call to call this function is Meteor first finds that we have a client version of the function defined called a stub, and it runs that first. And so then this message is printed to the console first. Once this is done, it makes an RPC call to the server to run the server version. And we get back a result and print that result from the server. And then that happens second. Now, it's perfectly fine to define these methods twice, once on the client and again on the server. But you can also put them in the same file and define it once. And this is useful if you have some JavaScript that runs on the client and on the server. Let me show you how. Now I've created a new file called both.js and commented out my previous method definitions. So I'm going to create some code in this file that will run on both the client and the server, and that's why I've dragged the window to take up both slots here. I'll call Meteor methods again, and we'll define the same method. But this time, this function will get called on both the client and the server because I'm not checking whether we're on the client and the server with that if statement. Now inside the function, I need some way of knowing whether I'm on the client or the server to decide what code to run. The way that we can do that is by using a property of this argument called isSimulation. So this can be a little bit confusing because we've used a couple of different vocabulary words now, including stub and simulation and client. But the API for now, for deciding whether we're on the client, is to use this isSimulation property. If that's true, we're running on the client. So if this is a simulation, I'll just type again that we're running the Meteor method stub on the client or the simulation. Whoops. And then we'll just return. If it's not a simulation, it means we're on the server. And so in that case, what we can do is return our hello result. Now let me recreate our client block, and we'll say if we're on the client, we'll make this method call, so Meteor call. And again, I'll pass this parameter and a callback function. And we'll just again say that the result from the server is whatever we get back. Now, instead of defining this function twice, we've just defined it once. And inside of its body, we check whether or not we're running on the client. And if so, we just do this and print this message to the console here. And if not, it means we're on the server, in which case we just return this string here. And on the client, we get this string back from the server, and we can print it out in our callback function as the result. And we can see that message printed here. You've probably already been using Meteor methods in your application, but I hope this video gave you some more intuition about what's happening. We reviewed 4 key concepts. First, we defined and called a method on the server. And then we looked at how we can call that same function from a client. Next, we looked at how to define a stub or a simulation method on the client to allow us to accomplish latency compensation. And then finally, we combined our client and server-side methods into one that runs on both the client and the server, using the isSimulation property to decide where we are.